Okay, good morning everybody. Today I will discuss new chapter F distribution. Before going to F distribution, what is meant by F statistics? The ratio of two independent chi-square variate divided by the respective degrees of freedom is known as F statistics. Or if chi1 square and chi2 square are two independent chi-square variate with n1 and n2 degrees of freedom respectively. F statistics is defined as follows: F is equal to chi1 squared by n1, that whole divided by chi2 square divided by n2. That is equation number 1. It follows it it follows F distribution with n1 and n2 degrees of freedom. What is meant by F distribution? A random variable is said to be Snedeker's F distribution with n1 and n2 degrees of freedom if its PDF is given by f of f is equal to n1 upon n2 raised to n1 by 2 into f raised to n1 upon 2 minus 1. This whole divided by beta of n1 by 2 n2 by 2, that into 1 upon 1 plus n1 upon 2 f, that bracket raised to n1 plus n2 divided by 2, that is equation number 2. F follows 0 and infinity. Now I will discuss properties of F distribution. The following properties are given below. F curve from 0 to infinity such that first to the highest n, then lags on the remaining, finally it becomes infinity. First property, it is a unimodal positively skew distribution n1 greater than equal to 2. Second property, if is a J-shaped curve for n1 less than equal to 2. 3. If more greater than or equal to 1 and mean less than equal to 1 implies skewness highly true. Fourth property, if tends to t-square distribution with n2 of n1 is equal to 1. Fifth property, n1f tends to chi-square n1 degrees of freedom as n2 tends to infinity. Last or sixth property, n2 into f follows chi-square n2 degrees of freedom as n1 tends to infinity. Next, applications of t distribution. The following applications are given below. First, f test for equally of two population variance. 2. F test for testing the significance of observed multiple correlation coefficient. Third, F test for testing the significance of observed sample correlation ratio. Fourth, F test for testing the linearity of regression. Last one, F test for testing the equality of several population, means this test is carried out by the technique of analysis of variance, which place is very important on fundamental rule in the designs of experiment in agricultural field. First one, F test for equally to population variance. Suppose we are independent to find if two normal populations have been same variance, let x1 x2 so on xn1 be a random sample of size n1 from the first population with variance n1 sigma 1 square, and y1 y2 so on yn2 be a random sample of size n2 from the second normal population with variance x sigma 2 square, then two samples are independent. Now we set up the null hypothesis H naught such that sigma 1 square is equal to sigma 2 square, that is equal to sigma square, say that is population variance are same. In another words, H naught is the two independent estimate of the common population variance does not differ significantly versus sigma 1 square not equal to sigma 2 square. Therefore, under the Null hypothesis of the test statistics f is given by f is equal to s1 square root by s2 square follows f, where s1 square and s2 square are biased estimates of the common population variance sigma square and are given by s1 square is equal to 1 upon n1 minus 1 summing I is equal to 1 to n1 xi minus x bar whole square, and s2 square is equal to 1 upon n2 minus 1 summation I is equal to 1 to n2 yi minus y bar whole square. Thank you.